In this video, we will talk about units and unit conversions. There are different systems of units. For example, there are the imperial units, which talk about feet and pounds and so forth. And there are the metric units, that use meters and kilograms and so forth. And when you need to convert between these, usually the conversion factor will be given. For example, 1 foot is equal to 0.3048 meters. There are different systems of units, and the one we will use, as mentioned earlier, is the metric system, also called the MKS system of units, which stands for meters, kilograms, and seconds, which measure respectively length, mass, and time. These are also known as the SI units, and in this course we will use SI units, and most of the time you should report your results in SI units. Though conversion factors will be given, you are expected to memorize the following prefixes. As you can see, when dealing with certain multiples of the fundamental units, meters, kilograms, and seconds, we have certain prefixes. So a centimeter, for example, deals with 10 to the minus 2 meters. A micrometer is 10 to the minus 6 meters. A teranewton is 10 to the 12 newtons, and so forth. A few more examples. A femtometer is 10 to the negative 15 meters. A microsecond is 10 to the minus 6 seconds. I should point out that that symbol there is the Greek letter mu, okay, and is used to denote micro. 7 megahertz, for example, is 7 times 10 to the 6 hertz, hertz being the unit of frequency. You would have heard of megahertz when dealing with radio frequencies, for example. And here we seem to have 1 kilometer equals 1,000 meters. However, this is wrong. The reason being that we have mistakenly put a capital K, which should not be used. The correct version is 1 kilometer equals 1,000 meters. Notice that we are using a small k. Whenever you're using the kilo prefix, it is a small k. Capital K refers to the Kelvin, which is a unit of temperature. For example, 0 degrees centigrade is 273 Kelvin. Besides these fundamental units, we will deal in this course with further units, for example, the units of force, the units of energy, and these are built out of the fundamental units. So, for example, the unit of force is a Newton, and you can see that I have represented it in two different ways. I've written it out explicitly, 1 Newton, and then I have also used 1N. The capital N here is the symbol for a Newton, just like a small m is the symbol for a meter, or a small s is the symbol for a second. Notice that when I write out Newton in full, I do not capitalize the N. If I capitalize the N, that refers to the person, Isaac Newton. So when using the units, use a small n if you write it out in full, but use a capital N if you just use the symbol for the unit. The unit of energy is 1 joule. Okay, the symbol is J. And these are related by 1 joule is equal to 1 Newton times 1 meter, or 1 Newton meter. Notice that I put a little dot there between the Newton and the meter. For example, I would not write 1 joule equals this, the reason being this is, on this side, this is 1 millinewton. And a millinewton is a unit of force, a joule is a unit of energy, and they are not the same thing. It would be acceptable to write 1 joule is equal to, again, 1 meter times Newton. In that case, you should remember to put the dot in between the different units. And in general, to avoid confusion between the little m for meter and the little m for milli, it's preferable, if you're referring to meters, to put it behind the other units, just like this. We have a Newton meter. We will see in this course that since it's only 26 letters in the English alphabet, we will run through them pretty quickly. As we have already seen, little m sometimes refers to milli, sometimes refers to meters, and you have to judge from the context which one is being referred to. And when you need to present your results, always make sure that it is clear and is clear to any reader who is just coming upon it. Usually, however, we will just say 1 joule is 1 Newton meter. So let's look at an example of a unit conversion. I give you the conversion factors. 1 mile is 1.609 kilometers. 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds. How much is 60 miles per hour in SI units? So 60 miles per hour is equal to 60 miles per hour times 1 times 1 times 1. Obviously, multiplying by 1 does not change anything. How are we going to construct these 1? Since we want to go from miles per hour to meters per second, we need the miles to go away. So, for example, we use the unit conversion between miles and kilometers and rewrite it as a fraction. Because if these two quantities are equal, then if I divide one by the other, the ratio will be 1. So I multiply by this fraction. How do I know which one is in the numerator and which one is in the denominator? I note that I need to cancel out the miles. And so if I have miles here in the numerator, I need miles here in the denominator. That takes care of the first fraction. Now I am at kilometers per hour. However, I want meters per second, so I need to get rid of kilometers. Again, since kilometers is in the numerator now, I need to get rid of it by using a fraction where kilometers is in the denominator. 1 kilometer is equal to 1,000 meters. The ratio here, again, is just 1. So multiplying by this fraction will not change anything, but it will help cancel out the kilometers and leave us with meters per hour at this moment. And then again, I need to get rid of the hours and turn it into seconds. This time, hours is in the denominator, so when I construct my fraction, I have hours in the numerator to cancel out the hours in the denominator. And again, this fraction is just 1, so it will not change anything. And this will finally cancel out the hours and leave me with meters per second. Now I'm just going through the steps, simplifying it bit by bit. Right now we're at kilometers per hour. Now we're at meters per hour. Now we're at meters per second. And so 60 miles per hour is 26.82 meters per second. However, if you have read the part on significant figures, you will realize that there's no way that we should have quite that many figures. And so keeping significant figures in mind, this is approximately 30 meters per second. When dealing with unit conversions, we have to take some care when we deal with powers of units. Here we have 1 millimeter is 10 to the minus 1 centimeters, or 0.1 centimeters. Another way of saying the same thing is that 1 centimeter is 10 millimeters. These are exactly the same relation. The difference is simply a matter of visualization. Do you prefer to think of 1 millimeter as being some fraction of a centimeter? Or do you prefer to think of 1 centimeter as being some multiple of millimeters? Each is a perfectly valid point of view. What is 1 centimeter squared? It is not 10 millimeters squared. Okay, 1 centimeter is 10 millimeters, but 1 centimeter squared is not 10 millimeters squared. Why? 1 centimeter squared is 1 times a centimeter squared, which means it is 1 centimeter times centimeter, which means when we want to convert into millimeters squared, we need 2 conversion factors to cancel out each of the centimeters. So this centimeter cancels with this centimeter cancels with this centimeter. The result is 1 centimeter squared is 100 millimeters squared. It is easier to understand this if we think about it visually. We know that a centimeter squared refers to an area. So let's say that this little square here is 1 millimeter squared. We are asking how many millimeters squared fit into 1 centimeter squared. If this little box is a millimeter squared in area, it's a little square with side 1 millimeter, and this big box is a centimeter squared, just think of it being zoomed in, okay? So the question is, how many of the little box fit into the big box? And we can see that 100 millimeters squared will fit into 1 centimeter squared. So 100 of these little guys will fit into this big square here. So when dealing with powers of units or exponents, for example, centimeter squared per second or meter cubed, stuff like that, whenever you have a unit raised to some power, always look out for the conversion factors. Remember that you will need multiple powers of the conversion factors as well. And so, for example, 1 centimeter cubed, right? A cube whose side is 1 centimeter. Okay, 1 centimeter cubed, we have 3 powers for the centimeter, and so we need 3 conversion factors. Each conversion factor gives us a factor of 10, so 1 centimeter cubed would be 1000 millimeters cubed. Finally, here is a question for you to work with and see if you understand. A certain canal has water flow through it at the rate of 5.4 times 10 to the 5 liters per minute. What is the flow rate in meters cubed per second? You are provided with the following conversion factors. 1 minute is 60 seconds and 1 liter is 1 decimeter cubed. The solution will be provided at a later date. Good luck and see you in the next video.